Okay, hello everyone. So back, let the people stream in a bit and then we can start. Hope everyone is doing good. So just to recap for the people that are not familiar with the setup, I'm going to code some stuff. I study some linear algebra mainly, and then there's going to be like a code associated with it. I'm going to struggle for a while, and if you have any question about anything machine learning or deep learning related, I'll be happy to answer that. The point is just that we have a kind of an office hour type of session. So about me, I'm a machine learning practitioner. I'm also I was a researcher for a while, still doing research. Got a paper published recently, and yeah. So my background is in computational neuroscience, if of interest. That's that. I wanted to start before going into the actual code to show you a paper that I've been reading this week, and honestly was a very nice one. It's not always that like I found like a good deep learning paper, but this one was absolutely amazing. So if you're looking for something to read, I highly recommend this. So this is called Continuous Thought Machine by Sakana AI. I like this lab. It's not like the usual AI lab where they're trying to like make a state-of-the-art foundational model and stuff like that. In their case, they're kind of taking like the stance that how to say it, like they're trying to make discoveries that are a bit counter the current like vibe. And this is actually something that I was talking about a week ago. I was talking about like the current like a large language system not being what's it like not having really a close connection to the brain in any sort of way, because they really had no state. Like they like it's a set of weight that you're gonna give it something, and then it will just output the stuff. When it's done, it's done. There's nothing happen. Like it won't remember you. You have to kind of engineer it to like have it remember stuff. So there's no concept of time with these models, right? And when I say time, it's like time in the sense that we as like a living being witness it, right? And when you look at other architecture, let's say RNN, I don't know, like LSTM, there is this concept of kind of a time and recurrence and stuff like that, right? But it's always associated with the data. It's not associated with some time dimension, right? So I don't know if you understand what I mean. So like in an RNN, it's like each of the input are passed one by one, and then like the model has a state that is going to be overwriting and stuff like that, which is cool. I find this is cool, but it's not this. Same thing with like large language model when they have reasoning, right? Where they're just gonna write to their input again and again and accumulate the stuff in their context. This is great, but it's still like kind of coupled with the data. This case, they made a deep learning system which has a concept of time that is decoupled from the data, which they're calling tick in this case. It's not really like second or stuff like that. It's really like ticks that goes on in time. And it's always in order to make a task, like I don't know, like a ImageNet recognition, whatever. But the image is there, the data is there, but the model will kind of go through its flow itself, kind of decouple a bit from this data dimension. You can think way more if you want to, or way less, right? They can have this kind of adaptive compute. So yeah, pretty interesting. It's a beefy paper. It's like 50 pages, but it's fairly readable. And the interesting bits here is that there's three main idea in this paper, right? There's this decoupled internal dimension that I was talking about. And then there's like this neuron level model / synaptic model they went for, where in essence they have kind of two models to modelize like what's going on with the given neuron. It's not something new, but it was done. I think it was well done. It was like each of the neurons are kind of independent and they can oscillate, right, however they want, and it's this oscillation that get put together, right, in a clever way to get an output. And the last one is like neural synchronization. So instead of like, I don't know, like having stuff in series, really, it's like you're taking the oscillation with the neurons into account, and then this is what you use to input into your attention mechanism and your output. And then like all of this with the tick dimension. There's actually like a really good figure here. So here, this is the synapse model. This is the neuron level model. And then with these two, you get like a proper modelization of the interplay between the different element. And it's kind of a graph because everything is connected to everything in some sort of way. And then like you see there's many arrows here because you have a concept of pre-activation with the synapse model that goes there. There's a history that is being kept, right? So that there's this concept of time for each of the activation. And then like this goes into the MLP, which is one for each neuron. And you get this post-activation, which is going to get feedback here for the for the synaptic model for the next tick. And then it get transformed over here with the synchronization, the attention to create the output that also get feedback into the model. So the model get like feedback like this again and again. And if you look, the data is kind of not central, right? It's here. Right? It's like a part of the loop, but it's not the whole loop. What you're using really is like the synchronization between neurons. Like this is what is central. And if there's no data coming in, the neuron will do stuff anyway, right? Which I think is very biological like, right? Like the I don't know, like the vision system of a human, like even if you're not looking at anything, it will still fire up, right? Even in newborn baby that never went out of the womb, it will still fire up and like oscillate and stuff. It has to do with like neurons. If they don't activate, they just die. But yeah, like that setup was fairly cool, and it lead to some really cool give me a sec. Really cool results I found. Like here, this is just like the neural dynamic for the ImageNet stuff, the post-activation. It's very rich, like the type of activation you get. It's not just like a ReLU type of activation. You can get many of them. There's multiple paper that like already tried to do this type of oscillation, but like these three things that they did was fairly novel. And then you can take a look at the process that like this model is looking at, right? So it's kind of also human-like. Like it's looking at the head here, and then it goes here, and then they decide, yeah, it's hockey here. It's a hockey puck, and it's a puck that we're looking at over here. And then there's a high certainty that you can have, and the model can know like how certain it is and decide if they want to go for more ticks or stop. So this is a high certainty environment. This is a low one. Overall, it was pretty cool. And this one is the coolest. I'm gonna try to find yeah, this one. I'm gonna try to find give me a sec. Yeah, like so this is what's happening as it look at an image, right? And there's oscillation in the model. This is like a projection of all the model. Like blue means like they're not very active, red means they're super active, and you can see like kind of propagation of like information really. And I find it cool. There's no concept of like localization and specialization yet. It's like it's all a bunch of neurons, but I found it very cool what they did over here. And you can see it in you can actually see it. Let's take a cute dog or something. Yeah, here, right? You can take a look at it, like how it's looking at stuff. So this is the average, and this is like each of the heads. each of the heads are like doing different things. You see, like this one seems to be looking at contour over here. This one is fairly local over there, and this one is more broad. This one is like directly on the nose, so it's kind of nose detector of some sort. But like each of the arrows is a tick in the model internal representation. So he was not certain, and at some point he got it right, and it was a bit more certain. It's still, I think it still got it wrong for this one because it's a hard one because it's a different sort of a race of dogs. But it's pretty cool. Like, and you can like open up the model and look at it, how it's behaving in more details. Yeah, overall pretty cool. And then like this experiment was also pretty nice. So like the idea is that you give it an image and then you want the model to kind of traverse the maze. Usually like even larger language model, they can do it, but it's kind of hard for them. But this one is pretty good at this, and like it's pretty intuitive how it's going about. So let's say this is the red, this is the green, and if you let it run, you see like it's gonna stop here, but because it's stopped at 100 ticks, right? And if you tell it to go again, so teleport, I don't know why they call it teleport, they move the red over here, I think it will get it right here, right? But you can, like if you look at the activation of the attention, you see where it's actually looking at, and it has like I don't know, like an almost human-like way of looking at the stuff. So here, this is a case, kind of a planning type of thing that it's going on. So this is the case where it can actually do it in 100 step. You start here, and if you look at the attention, some of the heads are looking at the green stuff. But if you look at the longer thing where like it can't get to the green, it's still planning the route, even though it can't reach here, right? Because this is the right spot to be, because you can then go at it in one path. It's still kind of mapped that they need to go somehow over here, but it knows that they can't just get there in 100 step. Anyway, that's a good paper. I highly recommend it. I'm gonna put this over here. It's very new. I think it went out this week. Yeah, highly recommend. So that being said, let's actually try to solve some deep learning question. We're gonna use this website, like always, pretty good one. I love it. We can take a look over here. It's gonna be question 48 today, which has to do with like reduced row echelon form. So there's a way to like get a matrix to row echelon form. So let's gather some intel. So this is sorry, here. Copy that. So let's say you have a matrix like this, right? A transformation matrix, and then like this is your A's, and then you have a bunch of X's in there. This is your weight, and then you want to transform this with a series of manipulations so that like you can get just a pivot here at 1, and then there's zeros right at the top if it's a pivot. So that's kind of the reduced row echelon form that we're trying to get to here. And that's pretty much that. The row echelon form is just with the ones, right? It doesn't matter if like there's 0 at the top, but the reduced one is when you have zeros above it. Yeah, that's kind of the general idea. Am I missing something? No, I think that's pretty much it. Okay, cool. So that's that. So let's read this. And in this problem, you test to implement the function that converts a given matrix. So this one, yeah, we should not have plain text. Into reduced row echelon form, the area of our matrix is a special form where each leading entry in a row is a 1. So in this case, each leading entry, this is a 1, this is a 1, this is a 1, and we have all other elements in that column containing the leading 0, leading 1 are 0, except for the leading 1 itself. There are some additional details to keep in mind. Okay. So diagonal entry can be 0 if the matrix is reducible. Okay, yeah. Some row may consist entirely of 0. Yes. If a column contains a pivot, all other entry in that column should be 0. True, right? Because if you look at it, it's above and below, which makes sense. Okay. Your task is to implement the which means all these cases and convert any given matrix to its rest. So if we have this, the output should be that. I'm gonna print that. Over here. Right, so this one is easy because it was already 1, and then we had to eliminate these two to get 0 over there. And then we knew that the next one need to be somewhere here, right? And then it will be 0 at top bottom. Okay. And this last one could be either all zeros or the one has to be here or here. Okay, that makes sense. So let's actually learn about this topic a bit. Or step-by-step guide implementing the RREF algorithm. There's many ways of doing it. If I remember correctly, I think it all starts by Gaussian elimination. So okay, start with the leftmost column. Set the initial leading column to the first column of the matrix. Move this lead to the right as you progress through the algorithm. Right. So the idea here is if we have, let's take that like this. Right. So let's take this. So we always start here in this column there, and this is our lead, and this one has to be 1. And then as we go, we're gonna move this like this. So we're gonna index like that a few times. Okay. Select the pivot row. Identify the first non-zero entry in the current leading column. This entry is the pivot. If necessary, swap rows to bring the pivot into position to avoid having a 0 in the pivot. Okay, so what we're saying is that, so once we identify that, this is 1, right? And then 2. So the level 2 here is we need to move like this. Yeah, like this, to figure out where we should be going. Yeah, so, yeah, okay. And then we look at each of them, right? So we'll look at this one, we'll look at this one, and this one. And our goal is to figure out here a non-zero element. So it needs to be non-zero. Non-zero here. And okay. Okay, we can swap, and then we swap the whole row. So if we do stuff, we're gonna swap like this. Okay. Then what do we do? Scale the pivot. Divide the entire pivot row by the pivot value to make the leading entry equal to 1. Ah, okay, cool. So, okay, so then we do this. We go like this. And by the way, what I'm doing right now, I'm just trying to fill up the shape of this algorithm. So trying to understand how it flows, right, through the through this thing. Right now, I know that I'm gonna have a motion like this on the columns, and then once I identify which column I'm working on, there's a motion like this on the rows to figure out which one I'm going to use, and then I just like move it up or down, right? Here they're saying something interesting. Identify the first non-zero entry in the current leading column. First non-zero entry. Okay, right. So it doesn't matter which one we are because we're gonna scale it. And once we figure out, okay, this is this one, right? Once we figure this one out, let's say it's this one over here, and it's highlighted by this right here, right? So what do we do here? So we scale the whole thing. Scale each of the elements, right? That's what we're doing, yeah. So the whole row goes and they get divided by the pivot, right? So this is now the pivot. So this is our pivot here. That's that. Boom. And if we get our pivot, if the pivot is 3 divided by the row by 3, magnetically leading entry 1. Okay. So at this point here, we got our pivot at 1, right? We got the proper pivot. Then we need to eliminate above and below the pivot. Okay. And then 4th step. Here, yeah, we go like this, and then how do we move? Subtract multiple of the pivot row from all the other row to create zeros in the rest of the pivot column. Okay, yeah. So then what we do is this, we go like this, and like that if we need to, right? I think it all depends on the, no, actually, no, we don't go like that. We go like this. It's always like that. It's just that sometimes we're gonna do it and sometimes we're not, and we're not gonna do it when it's the same index in both, right? And then like this one is a no, right? So this one is a no, we're not doing it. And then this one is a yes, we're doing it. This one is a yes, we're doing it, and this one is a yes. And then what we're doing is gonna be complete elimination here. What's the lead coefficient? So the whole row is like the row minus the row with the pivot, right? Times the lead coefficient. What's the lead coefficient? Subtract multiple of the pivot row from all the other row to create 0. Ah, okay, yeah, sorry, I'm just dumb. Here. So basically it's like we have the whole row, right? We have this whole thing. And what we're gonna do is we're gonna do let's say this, right? So this minus, and then it's gonna be something like this. It's gonna be that time, and then we're gonna just pick up this one, right? The lead coefficient, which is this, right? Times that, whatever it is, depending on like if we're like going through the rows, the columns, and whatever. That should be that, right? Because this is start with the 1, right? Like the element that is leading here, right? Our pivot here will be a 1. So effectively we're going to do 1 times the lead minus this, which is this. So this one will zero out for sure. This one will get like will get zeroed out. Okay, that makes sense. And that's that's it. And then we move to the next column. Move the lead to one column to the right and repeat the process from step 2. Continue until there are no more columns to process or the remaining submatrix is all 0. Yeah. Okay, cool. And then we move again. So that's our, and then like we go back here, right? So we go back here like that, and we go +1 in the column direction. Cool. Right? And then we move here, and then we should have fixed this. We find the one, we swap, right? Here there's maybe a swap element to it. So here, swap type function here. Okay. One thing though, so let's go through this one. We went here, this was the first, it was 1, we move on, all zeros, right? Then we go here, we know this one can't move. So as we go, so yeah, this is important. So as the index increase, the row gets locked in and cannot be used. So we're gonna work with less and less rows in this case. Okay, so this is good. And what do we do when we get to the third one? We get to the third one, it's 0, and we try to find another one. It's not there. There's still a 0. So we do nothing. If there's no one, right, there's a case here where yeah. So okay, here there is a case where everything is 0 that we can use, and we just pass, right? So this is that. Then here we look at the two of them. It could have been either or, it doesn't matter, right? It really doesn't matter. And then we swap them, and we decide, let's say we're gonna keep I don't know, we decide to keep which one. In this case we decide to keep I think this one. So we took the 2 and we swapped it up. Well, it doesn't matter really. And then based on this, we made it as 1. Oh no, wait, that's not true. Like no, it's dumb. Like these will get changed also. No, they just cannot be swapped, right? Cannot be swapped up. But they still need to be modified. Okay, we're getting there, guys. Like, yeah, I know it's a lot of setup, but we're getting there. I'm just trying to kind of understand as much as possible. And what I don't get, I think this one get eliminated, right? As we're making our changes to get the 0 here, this one just get killed off. Yeah. Okay, I think I get it. Yeah, I think I get it. So by following this step, the matrix will be converted into reduced reach leading on to is 1. Okay, so okay, this is good. I would like to just mess around with the notebook first. Last time I did that, it messed up my code. Well, I'll do it anyway. Okay, just gonna get that. It said when you leave the page or refresh your normal code, there will content. Okay, thank you. It's said here. Okay, so I'm gonna have my, actually, I'm gonna have that. I'm gonna do a plus here. I'm gonna have my ref. I'm accepting a matrix. And right now I'm just gonna print, hey, and return, just pass, right? That's what's up here. And based on that, I can print my code over there. And that should be good. So this is what I have. And the answer is what the output should be that, right? I'm gonna just do my test here. Def test f matrix, and we're gonna do yes, okay, result reduce matrix here. And then so matrix, so RF matrix minus reduced matrix. And then if we if I can, yeah, I'll just need to flatten it up. Okay, how do I use that? Okay, I'm going to, okay, diff matrix is this, diff matrix dot flatten like that, and I can just sum it, right? Sum. I think that's how we use it. How do we use that? Yes. Yeah. You can just do that. NP sum of this should equal to 0.0. No, just 0. Right, and then we return that. Okay. Matrix, and then reduced matrix. Cool. All right. Sorry. I'm setting test up just so that like I don't have to guess too much if I'm doing things correctly or not. Okay, so that's my stuff. And let's say let's actually test it. Did I forget something? What did I forget? With where? Line 8 here. Should be good. What's up? I think it's just because of the zeros. Should be good. Yeah, okay, it's all messed up. Okay, good. So this is that. That's that. Okay. Okay. Should be good. Okay, and then if I do np copy some that, and then this is my matrix. I'm just gonna take this for now. Okay, if I keep this to be supposed to be false, and if I just do this minus that, I get it true. Perfect, good, nice. And now for now, what I'm gonna do is I'm gonna do this, and I'm just gonna return the matrix. It does nothing else. So I can do my test and just do test RREF, and I have my matrix, and I have my reduced matrix, right? So that's really the result. For non-type, what is going on? Oh, didn't run that. Okay, perfect, good, got it. We haven't budged. We haven't done much. I don't understand anything. Can you give a tip where to start? What you don't understand? What I'm doing right now, or like programming in general? Like what part are you confused about? Let me know, okay? I'm gonna check the chat. Let me know what part you're confused, and I'll be able to give you some guidance here. Okay, so that's this. The math stuff. Okay, cool. Do you have a background in like machine learning or programming in general, or not at all? Okay, so this is good. Let's start with the first shot at it. Okay, perfect. You have at least a background in the ML. Okay, programming ML, good. Like you have to, like, math is math, right? Math doesn't care about machine learning. Machine learning is using math. Programming also is using math, and there's different math that are important. So like math exists purely for math purposes, if it makes any sense, right? So like the fact that you don't understand math and you never get it, it's okay, right? Like that's a very fundamental aspect that you need to understand. It's okay, like that you're a bit how to say it, you have a feeling that you're not fully grasping what's going on beneath, right? Because usually it's the case. Usually it's because you're not seeing the full tree of like from the really bottom to the top of what's happening, and that's fine. Like there's two ways really of oh Jesus, what happened here? Okay. There's really two ways of going about learning math, right? So math, right? The first way I like to learn math is just to pragmatically, right? So you can think about it as a pragmatic math. So what it means, like, to learn it pragmatically is that just learn it for its usefulness. That's it, right? And like this has a very top-down feel to it. So what I mean by that is, I don't know. Let's pick the paper from last time, right? Like this one. We've looked at this paper, and there's some math in there, right? You go over here. Let's say, where is it? I think it's a bit down. You go over here and you're like, ooh, what's going on here, right? What? Why? What is happening? Like, for what reason do we have like diagonalization of matrix of something here? There's these two that are kind of similar and that like get transposed. And what's a transpose? And then there's this aspect here that we're doing a summation of some sort, and then like a square root, it seems, of sort. Like, you take that and you dig here to understand what is going on, right? And then you take it as this is the end of the learning. This is the goal. So you take that little thing right here, and then you're gonna dive a bit deeper on it, and then you're gonna learn just enough of the topic, right? Just enough about each of the topic to understand why this is, right? Why here, right? And that's how you do the learning. And then like, so you're gonna open up each of the little component, right? Not as like you're gonna read this and then you're gonna understand it, because it's never like this. It's never like you're gonna read a line of math and then just gonna get it, unless you already read it multiple times or like and stuff like that. Usually math is slow, right? Math, you're gonna look at this, you're gonna get, okay, where I'm at, right? What is the R here? So R is like these components, so these R component, little R component here, that are kind of like scaled with an exponential, and then it's like decaying kind of in time. Okay, I get this part, right? Took me like 20 minutes. Then you go down and then you eliminate each of the point, and then you sit down and you look at the whole motion, right? And then it's gonna click, right? The exact why it's clicking and why they did it like this, not another way, you're not gonna get that, right? But you're gonna understand why they did like these particular set of math motion and like why it should work, right? So this is the first one. The second one is more dangerous, I would say, right? The second one is the first principle math. Principle math. And you can get lost here, right? I saw a lot of people got lost. Yeah, like you can get, so what I mean by first principle is that you look at like each of the little component of mathematics, right? And you try to learn it really well, each of the component, and then the component will build up, right, in some shape. And then this thing will be a bit more complicated. And then you're gonna use that for making like this thing, but you also need this other thing over here. And then you're gonna build your understanding like bottom up like that. This takes years and years, and if you're not careful and you don't know where you're going with this, you're never gonna make it. Like either you're gonna end up a mathematician if you love this stuff and you're okay getting lost forever in this, or you're just gonna get like frustrated. That's what's gonna happen, right? But this is the most powerful this is the most powerful understanding. If you get this, right, that stuff is trivial, right? You're gonna be like, whatever. And then you're gonna understand all the nuances, all the colors, all the movement that is happening and what they could have done instead, right? And then like, it's almost like jazz. You're gonna be able to do math and change stuff because you know it's right. You know the shape fit, right? People that like did this work and then like understand clearly the first principle math are like much stronger than anyone that is just doing pragmatic math, right? They are few. Like that's the issue. And the reality is that you're most likely not interested enough in math to be a first principle math type of guy, right? That will be able to do jazz with it. And it's fine, right? Because there's other stuff in life than math, right? So what I usually advise is pragmatically, you should go this. You should do this like most of the time, right? And what will happen is that in that, like, let's say this is your understanding, right, of the stuff. Okay, let's put it in red, right? This is your understanding or lack of understanding about the topic of math, right? What you're gonna do is that you're gonna use these things, right? These little problems that are useful for you, to kind of like just do a depth first search here, just enough of what you need, right? And you're gonna do it again here, and then do a depth first search. You're like, okay, fuck it, I'm out. And then same thing here, but then oh, now you see, and then oh, it's overlapping with something I already understood. Wow, okay, and then you keep doing this, right? You see, it's all squiggly, and it's like not, you never go to the core of it. But what you do after that is from time to time, right? You pick a month of the year, right? Whatever, and you're gonna learn about a first principle type of way where there's not gonna be an end reward. You know this, right? In this case, there's an end reward because you're gonna understand this bit of code or this bit of method, which will make you a better machine learning practitioner or like a deep learning researcher or whatever it is, right? In this case, it's not initially gonna make you this, but what it will do is it will make you understand this whole area like this, right? A bit better, right? So it's not connected to the outside here, it's just connected inside. But you're gonna be like, you know what? I don't know. Probability distribution, I got this on lock. I understand it. Every time I'm gonna see this, I'm gonna be good. So next time you're like, I don't know, looking at something, let's say you're looking at GRPO, right? And then there's this topic called KL divergence, and you're like, oh wait, what is it? And then you understand that like it's like two different probability distribution that you're comparing together. You're gonna be like, oh, it's not that complicated, and then you're gonna be able to get to your zone of understanding that you went and built from first principle, right? This is good. So it's kind of what I would do, right? So you focus here most of the time, pragmatic math type of shit, and no way you're not gonna be doing proofs and stuff, right, with this type of knowledge, but you're gonna know what's going on, and you're gonna be able to explain it, right, and then use the little math tools to your advantage. And from time to time, you do the first principle math type of stuff where you're gonna understand things deep enough, right, and you're gonna have the patience to do it because you know that this is useful in some ways, maybe in ways that right now you don't know, but you're gonna get like this intrinsic kind of reward of I'm making this understanding of math a bit better for myself, right? And then you're gonna keep going, and maybe I don't know, like maybe you're gonna love this at some point. You're gonna be able to push through and get at some point more and more of these areas that are greener. You're gonna maybe get less anxious when you see math because you'll be like, oh, it's just something I don't know yet from first principle. Let me duct tape it for now, right? And then you just go do the work that you need to do, right? You know you have to go slow, and then you pop off and you're done. Well, that's what this is not what your teacher will tell you, right? But this is realistically what you should be doing, right? If you go to ballsy and you're like, you know what, I'm gonna be like a whiz in math and I'm gonna do just the first principle, and you don't have like this passion in you for this subject, you're not gonna make it in any shape or form that is useful for yourself, right? So I will always tell you, like, start from the end, so the top, right? And wing your way through it whenever you need to, and then dive deep whenever you have the courage. Yeah. But I would say, like, you can't just do the pragmatic stuff, right? At some point it will break. The duct tape is still duct tape. But the first principle math, if you have enough duct tape, you know which part you have to triangulate a bit better, right? And you know that this part that you haven't used yet, someday you might use it. Okay, enough blabbering. It's actually good. I hope this is useful. Let me know if I answer your question. Okay, so first thing that I need to do is I need to iterate on my column properly. Is it always square? It's not always square because this one is not square, right? Yeah, I need to know how long, like I need to know the row and column. Okay, so row, you can get that from the shape of the matrix directly, right? Glad it was. So matrix dot shape Okay, so this telling me my what? This is telling me my rows. So this is my row length, and this is 0. Yeah, okay. Row length, call length here, right? That's right. I think I got it. This is 3, yes. And this is what? 4. Perfect. Good. We got it. So good. So first off, I'm gonna do this over there, right? Because I know I'm gonna need to kind of move through this, and I'm gonna move through the rows, and this is deterministic, I know. So for I in range call length, and here I'll call it call I, the index at I for colon, and yeah, so in this case I'm gonna iterate through the columns, and it's gonna be fine. Okay, so that's my main motion. So this is the main. So here, main motion through the columns, which is this one, right? That's my main motion. This is always gonna be, right? And within it, within this one, it will dictate to me like yeah, it will detect to me like what I should be doing at this point. This is my pivot, and this one can have all of the row involved. I can't make an assumption about like how many of these rows I have. Yeah. So okay, main one. I think we're good here. We're good with the main motion. But now is that what they said here? Yeah, perfect. So one done, and I have to select the pivot row, right? So here I have to select which row to work with. I think, yeah, I think this is good. I think I'll be able to. I think I'm gonna encapsulate most of the stuff in smallish function and just debug that, and I think that would be easier because last time I struggled for so long. So def select pivot pivot row. Is that it? It's a pivot row or pivot column. Pivot row, right? Okay. So I'm gonna select the pivot row, and I have a matrix that I'm gonna give it, and I'm gonna have like it can't skip. It cannot skip a row here. It can't skip a. I'll have to know which one are actually pivot, because here I say as the index increase, the row get locked in, cannot be swapped, but they still need to be modified. I cannot swap them. But here, when I'm there, I could still swap these one, even though I passed through this one. But the column ID is not telling me that. But I mean, it just means that I can just swap these, right? Swap the remainder, the remainder of the rows, I guess. I'm trying to do this swap thing. I'm not sure. I'm not really sure how I'm gonna do it. Like, theoretically, you could swap everything all the time, but I think at some point I need to lock in some rows and say like, yeah, this one you can't swap it, because if you do swap it, the pivot is out of whack. Yeah. Yes. Because you see, when I get to here, it's a 0. I can't swap it with these ones. Should I give it like should I give it a bunch of index that they can't use? Should I have like an array which has the indices of the elements, the rows that have been locked in, or every time I move one, one like this, no, yeah, I think I have to do this. Okay, so here what I'm not sure here is like, I want to lock some of them that are finished, right? And I think what I need to do is I'm gonna give it locked rows, right? I'm gonna lock some rows as I'm going through them, and I'm gonna add the indices of where I'm at, and once I'm there, and when I'm gonna try to swap, I'm just gonna skip it and then not look at them. And I think that's kind of how I'm gonna do this one, because then every time I'm done with the row and I have a pivot that I've found, I can just add it to the lock. I think that's kind of what I'm gonna do here, right? Okay, so here, before jumping to next column, if you created pivot, you lock the row so that no swap happens. I'm pretty sure that's not the way to do it. I'm gonna do it anyway, so that I'm gonna do that. So I'm gonna have my locked rows here, and I have to give it my column, I guess. Current the column. Yeah, so I give it my matrix, the full one. I give it my I can give it my full matrix, I don't care. And I'm gonna index into the right column, and I'm gonna look at each of the element. I think it would be easier if I could index. It doesn't matter. Okay, I'm gonna do it like in knucklehead fashion, and that's gonna be that. So how do I select? How do we select a pivot row? So this is my question, and my answer to that. Can you all see properly? Yeah, I think I'm gonna zoom in a bit. Can I zoom in? Okay, I could. Just gonna put myself a bit smaller here. Okay. So how do I select the pivot row? And then it says here, identify the first non-zero entry in the current leading column. Yeah, the first one that is non-zero, right? And that is not locked also, right? So first non-zero that isn't locked. So I start at the top for for row I in range in matrix, I guess, right? And then I index current row equal current element equal my matrix, my row first, right? So my index row. Wait, no. This is my row. I'm gonna do row at my column. Okay, at my column. If current, no, I need, yeah, I'm not gonna do this. I'm gonna need to have the index of where I'm at right now. Yeah, matrix dot shape 0, and then I'm gonna do a range here. Yeah, that would be, I don't think it's optimal, but it will be easier for me here, because this, it will just select the pivot row. So I have my matrix at my row I and at this current column, right? And that's my current element. If the current element is not equal to 0, then we're gonna return row I. Yeah. And else, return -1. So this is the case where it's all 0, right? But it still will not work because I need to pass, right? So here, if row I in locked rows pass, I would say continue, right? Pass over the rows that you can't touch. Right, I think that's seems to be the motion, I guess. Okay, so what happened here? I have my matrix, my locked rows, my columns, the column column I, I'd say, right? That's my index. And then we select the first non-zero that isn't locked. So I go through each of the rows, right? And then I check if the row at I in locked row is in locked row. If it is, I just pass over it. And if not, then I'm gonna go here. I'm gonna take my current element. And if my current element is not equal to 0, I'm gonna return it. If it is, we just go to the next one and the next one. At the end, if like it was just not possible, I'll return -1. I think that's not too bad. Let's test this one. Select pivot row. Okay. Okay, so select pivot row. Let's give it my matrix. Let's give it like nothing, and let's give it let's say we're at column 1, right? What will be the answer? 0, the first index. Okay. And well, this is good, but it will always be that for this one. Let's use instead the reduced matrix, right? And if we give it 0, should give me 0, and then 1 should give me 1. Okay. And then 2 should give me 2, right? And then 3 should give me 0. Perfect. Okay, so let's say we give, we're at the first column, but we still have something like the first column, it's not possible. So I give it giving me -1 because it went through, no, it can't swap this one. Look at those two, they are both zeros. So if I give this 1, 0, 1, 2, right? And then we're at column 2, -1. And then here, 3, give me -1 still. Perfect. I think we're good. I think that's working. Okay, so this is good. I think it's not too bad. Check the current element is not 0. If yes, that's our pivot row. Okay, good. We're making progress here. And what I need here is like locked rows. At the beginning, it's nothing, right? And then as I'm going through this, if I'm actually using it, then I'm gonna lock it. Yeah. So select pivot row. Yeah, okay, that's good. So pivot row, I'm gonna give it the matrix. And this one I'm gonna change multiple times. I'm gonna give it the locked rows here. I'm gonna give it the column ID, and it's gonna be like my pivot row, right? So step 2, select a pivot row. And step 1, Jesus. Step 1, what are we saying in step 1? Okay, iterate over the column, starting from left. Okay, guys, we're getting there. We're making good progress, actually. Usually my style of programming is that like there's a lot of mapping and documentation, and then everything just boom converge at some point or not, and I'm stuck on it for like 4 hours. Okay, so I think I'm good now. If the pivot row is not good, so if pivot row is equal to -1, right? Nothing to do on this. Yet nothing to do on this. In this column. So with this, I'm gonna get my here, right? If these two are locked and both of them are 0, I just skip it. So here, I just continue, right? And continue will go to the next iteration, and we're good to go. Right, I think this one is good. So we select the pivot row. What's up after that? This entry is the pivot. If necessary, swap rows to bring the pivot into position to avoid having a 0 in the pivot position. Right. How do I do that properly, cleanly? All right. I think the locked rows need to kind of go and follow, like at first, the first locked row will for sure be at 0, right? And then the second locked row will for sure be at 1. And the third locked row will for sure be at 3. Even if like here where we don't do anything, the next one need to be at 3. It can't be at 4. Otherwise we're gonna have a gap here, and that's just not gonna work, right? And if it's at 4, yeah, it just can't be. It need to be okay. So the lock row need to be to follow. So then I just swap the pivot. So here, this is 2A. Let's say 2A. Step 2B. Bring the pivot row to the next I feel like locked row is not the best naming here. How can we name this properly? But is it really locked? Okay, naming. Yeah, I don't know. Like for now, like let's put a to do here. Find a better name for this. To the next locked row indices, right? And this gonna be, it's gonna be what? It's gonna be the element at locked rows -1, the last one, +1. That's gonna be main current row. Yeah, that's the current row that we need to work on. Current pivot. Let's say I think it's called pivot. Yeah, I have to call it pivot rows or something like that. I think that's gonna be better. Anyway, I'm gonna call it pivot row, current pivot, row I, let's say. No, this is garbage. Like this is not. Like I would say like next. Yeah, no, let's call it next pivot row I. Same thing here. This is not the literal pivot row. It's the pivot row indices. So let's name it as such. Okay. So if the pivot row that we found is not equal to the next pivot row I, right? And here we need to swap. If they're equal, we just move on. We're good. Like there's no problem, right? So right now I'm trying to do is like find the pivot row, and if it's not at the right position, I'm just gonna swap it, right? And once I'm swapping it, I'm good. I can just move on. Do I even need to do that if I'm going like sequentially like this? I could have a 0 here and a 1 here, theoretically, right? And if that's the case, I just need to swap that. Yeah, okay, so that's fine. Okay, how do I swap that without fucking it up? Okay, no, I think it's good. Okay, so temp row equal matrix at current, sorry, pivot row I, then I take my matrix at pivot row I, put it equal to what is in the matrix at next, and then I take the matrix next pivot row and I put it equal to the temp row. I don't think it's gonna work this way. Numpy swap rows. Yeah, I don't think it was gonna work out. Yeah, I think no, there's a better way here. Yeah. Okay, no, this is good. I like it. Okay, so to swap, I'm just gonna do this. I'm gonna do matrix, and then I'm gonna have my indices here equal, and I'm gonna have my indices swap here, and then I'm just gonna do this. I'm gonna do next pivot row, and then pivot row I, and then opposite. Wait. No, this one is a good one. Yeah, that would be a good swap. I think they're equivalent. I don't think like I'm doing anything illegal here. Yeah, I think that's still good. So next pivot row. Oh, it's very verbose here. Bleh. Okay, whatever. So swap the two. Swap the two rows. Yeah, good. Okay, so we're doing a swapping here. Are we good here? All right, moving along. So bring the pivot row to the next row location. So here we did a swap type function, and then we scale, right? Then I technically have everything I need. So at this point, at step 3, scale the right row with the column, with a pivot, right? And this is our little formula here. So it's not too bad, right? So basically it's gonna be matrix at a, where are we? Okay, then. Okay, at this point I'll just do pivot row I equal next pivot row, right? So at this point in time, I can just use pivot row. I don't care about this one, really. I really don't care about this one. So I can just do that, and I'm gonna go pivot row I, and I'm gonna take it out my column I element, right? This is where we're at. So this is gonna be my pivot value, right? Is this how it's called? How do they call it? Yeah, the pivot, right? I'm just gonna do pivot value, and I'm gonna take the whole thing, do matrix pivot row I, scale by a scalar. I think that's that. Yeah, that's it. So I can just do this divided by the pivot value. And I take all this and I just jam it straight back here. Should work, right? Scale the right row with the pivot value, and the right row is going to be a pivot row. We take the element. Yeah, I think it's good. Yeah, I think we're not doing too bad right now. Okay, cool. So this is easy, I think. Like so we're done with this. We're done with that. We're technically also done with this. We can scale it, and now we need to scale everything else. Absolutely everything else. So subtract multiple of the pivot row from all the other rows to create 0 in the rest of the pivot column. This ensures the pivot is the only non-zero entry in its column. And it can't fuck it up. Like it can't. Well, can it? Yeah, okay, cool. It will not change like these rows because it's always going to be with 0. Yeah, okay, I think it's good. Okay, cool. We're almost there. I think we're almost there here. Step 4. What do we call here? We said eliminate above and below pivot. Eliminate above and below pivot. So how we would do that is we're just gonna be a for loop here for call, I would say j in range. We're gonna go range called blank here. So we have to start from the 0 from the base here and everything that is not 0. So oh no, wait, so this is on row I in range row length, right? We go tuck 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 and it's at this column that we're checking. Okay, so current value, how did they call it? They call it lead coefficient, right? So lead coefficient equal matrix at row I, and then we have the call I, right? Because we're at this column. It doesn't matter. We could still scale it, even if I'm just gonna do it straight here. So yeah, I know. Like I'm gonna copy paste the whole thing before I move out for sure. Is there a way to save this? That would be nice if it could be saved, Mo. By the way, guys, for those no, Mo is the guy that is maintaining this website. So yeah, okay, cool. So we have the lead coefficient over there. So we're gonna go here. If this is 0, I don't care. I think it's fine if it's 0. And yeah, what was the formula again? So like, and this is the row of the pivot, and I'm just gonna scale whatever it is here in my current row. I think that's fair. I think this is fine. So I'm gonna go matrix at row I equal matrix at row I minus the matrix at pivot row time lead coefficient. If the lead coefficient is 0, nothing happened, right? If the lead coefficient is not 0, I'm gonna scale it by whatever is in my pivot row, which it should be 1. No, wait. Yeah, I just need to do it when I'm like I'm at the proper spot, otherwise I'm gonna get a 0. So if row I equal pivot row, I'm just gonna continue. Right. Otherwise I'm doing this. So skip your row, your pivot row, and then eliminate the columns element with by rescaling whole row. Is this fine? Yeah, it's fine because it's the lead coefficient I'm taking, so it's for sure going to be 0. So for instance, like this is 1 times the lead coefficient. When I'm going to get to this row, it's going to be, this one will be like, I don't know, 5 5 times 1, 5, just get out. Okay, and the rest gets scaled to whatever it needs to be scaled, and we should be good. We're making notebook saveable, but currently it's not. It's more of a scratch paper. Cool. Yeah, doesn't matter. I think it's still fine. I prefer to work with this. One thing that could be cool is that, I don't know if it's possible. It's just like have an area where like it gets saved. I don't know, to the actual thing, right? And I don't know, it's not editable or something like that. So that you can test out stuff, but then like I don't know, a cell is protected or something. I don't know how much granularity you could have over there. Maybe like you can have a cell name that is tagging this so that you can mess with it. It's connected to the other thing. I don't know. Okay, that should be good. I think this should eliminate everything above and below at this point. Yes, I think we should have done that. Yeah, and then we just move, right? I think before we move though, we need to do our little thing. We need to put this into the locked rows. So here, step 5, prepare to move column. And I'm gonna do locked rows dot append whatever pivot row I have right now, right? And it should be good. Yeah, should be good. Okay. No way this is gonna work. No, there's absolutely no way this is gonna be valid. Yeah, for sure this is gonna break. Okay. Locked row -1 is index out of range. Oh yeah, of course. Because at first it's gonna be nothing, right? Can I use a ternary operator Python? So I hate that. Yeah. Because this is bring the last element here. Okay, so we do this. If length locked row is bigger than 0, else we just give 0. Okay. I have to do this because otherwise, this lock row is not empty. Okay. Why is it working? What? Why do I have a true? Is it actually working? What the fuck? No way I got it right. There's no way. There's absolutely no way I got it right first time. Impossible. Wait a second. No, yeah, this is all garbage. Wait, why the fuck is the matrix this? Okay, I get this, and what happen if I do? Yeah, wait. I'm actually right now debugging debugging the fact that they might have worked. Okay. That's how I don't do that. What do I get? I think it's working. How come? I can't believe it. No way it's working like that. Okay, wait. I'm just gonna put everything here. Folks, we're about to make the big jump. Wait a second. Where can I scratch this? Put it. I'm just gonna put it on collab for now. Yeah, but like, I'm debugging now, but it's just working, which is not usually not possible. Usually, like when it's working like this first shot, it's so messed up that it shouldn't be almost. Yeah, I can't believe it. Okay, so make the big jump because now it should be kind of deleted. So let's see. Get myself over here. Gonna take back my code. Right here. That's a bit too zoomed in. Okay, and I'm gonna replace my RREF matrix. Put it there. Let's see. Okay, yeah, for sure. Okay, I got some edge cases. Nice. Okay, so this one I got it right. Because nothing has to be done in this particular. Well, yeah, no, this is good. I did some stuff. In this particular case, yeah, it's a bit too aggressive on this one. And this one, and this one, and then I got a 0 here, but a 1 here. Okay, no way. Yeah, this one I didn't get it right. Here I was expecting 1, 1, and then 1 here, but I didn't have that. I had 0 here. Okay, and test case 4, what happened? I have 1, 2, 0, good. 0, 0, 0. I don't have that. I have 0, 0, 1. Yeah, I have no clue. I have 0 clue what's going on. Thank you, Karthik. Don't hesitate, folks, if you have any question while I debug this this pile of mess. At least if everything was red, it would have been a pretty easy, straightforward debugging. But now I have half of them right. Where did I miss? I think there's like a sub element that I didn't take into consideration. Can I go back? Can I jump back here? Oh, yes. It didn't destroy everything. Cool. Woohoo! Okay, so I'll take this test case. I don't need to. I really don't need to. I just need to look at the algorithm a bit clearer. So, but this first pass is not working at all. Wait. No, it's not. Absolutely not working. I think I'm doing the swap properly. But there's something not right. So I'm doing the swap here, right? Yeah, this is where I'm putting the stuff. This is where it should. Is this how we do it? Wait a second. Yeah, I think this is how you swap. So you have like where it should be, where it is, and then you just take that whole row and then you move it. Okay. Swap, I think I'm confident here, right? Column, I'm just moving through the column. Pivot, selecting the right pivot. Yeah, this one I'm not confident because like no, it's not. It's not selecting the right pivot row. Yeah, in this case, this is where they messed it up. 1 0 0. Okay. Yeah, it's messed it up here. It should have selected. No, that's good. But actually, I have no clue if it's good or not. I don't know. I don't fucking know. Yeah, man, this one gonna debug it for like the next 3 hours, folks. Like that's gonna be it. It's gonna be me looking at the. This is gonna be me looking at this for like 3 hours, and not changing one thing, right? Every time I'm doing this is what happened. Okay, let's take step by step here. Right, I'm prompting myself like a reasoning model. Step 3, scale the right row with the pivot value. I got a feeling that this is fine. I don't think like this is an issue at all. Yeah, I don't think this is where I fucked it up. Taking the pivot value, maybe like eliminate above and I think eliminating above and below is fine too. I don't think this is where the issue is, because otherwise I would have to have the zeros at the right spot. Maybe it's too aggressive because I'm always having, no, not always. 1 2 0. This is good. 0 0. No, this one is all 0. And I have 0 0 1. I don't know. I don't know what's up. No. Wait a second. If I take this whole thing, I'm gonna draw it up, right? What the heck am I doing? So at this point here, I have 1 0 0 minus 11, right? And in here I have still a 0, a 1, a 0, and a minus 7.5, right? So far so good. And in here I have a 0, another 0, a 1, and a minus 11, which makes a lot of sense, right? What the fuck did I do? I did 1 0 0 0, and then I did 0 1 0 0. Oh, what? 0 0 0 1. What happened? Why is the first one all messed up? Oh, wait. I think it continued. I think that's the issue. Because if I hit here, and I have, no, I think there's an early stopping. So because if I hit here, I don't have to do anything, right? Like you could technically have Yeah, like if you fill up all of your rows, you should stop, right? I don't think you should go. Otherwise, you're gonna eliminate yourself. I think this is the issue because wait. So yeah, I think I have an early stopping issue here. So I think it's here. Yeah, I think it's here. Or here? No, I think it's at the end. And then final stopping, final check. If length of the locked rows equal the number of rows, right? The row length over here, we just return, we're done, right? When early stopping check, when complete, when found all the pivot rows. I have a feeling this is it. What do you guys think? Nope. It was not. That was absolutely not it. No, that was not it at all. That was actually pretty dumb. No, I didn't do anything here. I'm just gonna print this. Locked rows. So 0, 0, 1, 0, 1, 2, and then we stop. But if we stop, why are we doing all this shit? I don't think it's a swapping because I should be good. But I think here at this point, we're doing something wrong. Here maybe. Yeah, maybe it's there. Because like how could we eliminate the element that is here, right? Yeah, I think there's something not good. So here, wait. To do check if needed. I think it's needed, but I'm not sure. Yeah, I'm not sure at all. Wait. Because we're iterating about the column here. No, I think it's fine because I think in any cases it would already lock the row here. So no, this is useless. No, sorry. I take it back. This is completely dumb. It's not that. I think the issue is around here. I'm just gonna print the matrix at this point all the time, and print, let's say, the current column. Yeah, call I here. Let's go. So at 0 we have this full matrix. 1, 0, 0, minus 5. Okay. At 1 we have this matrix. Hey, whoa. It gets eliminated quite early. There's no more 1 here. There's no more anything. So what do we have? We 0, 2, minus 1, minus 4. And you have 2, 0, minus 1, 11. Okay. Okay, but where does this one? Okay, we swapped these two. We swapped this one and this one together, I guess. And we kept this as is, right? This is what we did. We just swapped them. And I believe we rescaled them. What is this whole pivot value rescaling? How did we rescale that? We did. But we only have. Is it because we only have integer? Why do I have a 5? If it's a minus 11. Is this the issue? I don't think it's the issue. Yeah. We'll move on. And we get completely eliminated. And here I have nothing. Then this one stays. And are we shaping this in any way? 1 minus 2. And we have 12 here. What the heck is happening? Wait, so 0, 0, 0, 12. And then column, when we're at column 3, we have 1, 0, 0, minus 5, 0, 1, 0, minus 2, and 0, 0, 0, 1. I have no clue where it is going on. Oh, I think this one should have been the first. Is that it? Is this the issue? Because these two... Because if I take this one... Is there multiple solution? Like in a reduced row echelon form? Is this? Is there? No, it should be unique. No, yeah, so I'm just not doing it right. So why, okay, I'm taking this one. I think it's the first thing that I'm doing here. Start with the leftmost column. Start the initial leading column to the first column of the matrix. Move the least lead to the right as you progress. Identify the first non-zero entry in the current leading column. This entry is the pivot. If necessary, swap around, bring the pivot into position to avoid having 0. Yeah. Huh. But if I take this one first, then I have a whole bunch of zeros. Because that's the issue right now. Like the issue is that this buddy over here should have been the first, and this one, but how can I make it so? How can I like get this guy there? So you get me like a weird response, a weird answer. The algorithm seems to be doing it what it should be doing. But in my case, there's a gap, right? If you look at what I've done, there's a gap here. That column, right there. But I think it's still fine. But it's just like everything get obliterated. I just stop earlier. What's the intermediate step here? Just before I commit, I have 1 0 0 minus 5. But why minus 5? No, it's 5.5, something like that. All right. How did I get that? And I don't think I even copied the right stuff, because this is 2 0 minus 1 minus 11, and I get 1 0 0 minus 5. How? I think this is the issue. I think that part right here is the issue. I'm just gonna move it up. Okay, so this is okay, so to do that I scaled it, so I'm just gonna move it up right here just before the rescaling. Let's run it again. So the only thing I should have done here is a swap. So okay, I have 2 0 minus 1 11. Which is this, and I swap the 2, right? But then I end up with 1 0 0 minus 5. Am I dumb here? What the heck did I do? What the? Is it the scale? I think it's the scaling that is like off whack completely. Alright, so okay. Current column here before scaling, and this is after scaling. Okay, guarantee this will be like some dumb mistake I made, like for sure. Okay, so before the scaling, I'm just gonna put myself here. So before scaling, we have 2 0 minus 1 11, and after scaling we have 1 0 0 minus 5. What the heck? How did I get to that? I scaled by what? Divide by 2? Is it just a matter of like this not being a float? Is that it? That's it? Just that? Is this the only issue? Okay, wait. Pivot value is this. This is 2. Wait, what is it? Yeah, it's a 2. But like, what is at matrix pivot row and at 0 1 2? It says 0. Like, is this the type? Okay, like, wait, what the heck? Is it an int? No, I don't want an int in there. I want a float. Why is it that? Alright, then that's the issue. Yeah, I think this is the issue. Okay, I think I can just like prepare it here. So matrix equal matrix, and then I'm just gonna do as type float. That should be doing the trick. Is this it? Ah, sorry, I meant that. No, it doesn't change anything. No, oh, sorry, it's not this one. Here. Okay, well, did I just fix it? Oh yeah, got it. I got it one. Yes, I got one. Nice. Okay, we're making some headways. So what just happened is that it was treating this as an integer. So I got like a 0 when I should have a 0.5 or something, which like zeroed out the whole column. It was just a matter of like making this as type float. Yeah, I think that like this. I think this should have been a type float from the very beginning. I don't think like I don't have control over this. Mo, if you're there, maybe just like put that into a float, and then I think we should get that sorted. Okay, so like this is good. So we have 3 out of 4. We're getting there. I think the last one should not be that hard. What do we have? 1 2 0, right? 0 0 1, and then how 0 0. I can have 0 zeros like this. Okay. So what's the issue? Oh wait. Is this really a mistake? Right? Like I don't think it is. Like yeah, what's the difference here? If I have that thing down there or this thing up here, same stuff. Like this should be literally the same stuff. Like what's the difference, right? In this particular case, I think I'm right. What do we have? We have 1 2 0, and then we have a bunch of zeros here, 0 0 0, and then we have 0 0 1, right? And in this case we have, in my case I have 1 2 0, and I have 0 0 1, and I have 0 0. Come on, same thing. Well, how is this? Is this better? This having no, I don't think this is good. Yeah, this is better. My output is better. Am I in the right here? It doesn't matter at all. Because in your case, like you're not even locking the row, you just move on. And you have a row of zeros straight in the middle. Wait, I think I'm dumb. Well, is this it? Is this like something like this? Like anyway, we're gonna do like locked rows. What is it that we're... Is this the issue? So let's say I'm in my select row. I give a -1, and we just do nothing here, right? But in my case, I'm like, yeah, if we have nothing, we just move on. But in this case, like I went here and I was like, yeah, fuck it, we just move on. But then in the next iteration, when this was down, which I have no idea which one is it, but like I had to swap one of them, I think. I'm not sure. But this feels like a bit redundant here. Why, like, this and this are valid in my view. It's the same thing. Like, there's no difference. Is there no difference? I feel like this one on left is wrong. What? We're gonna get some AI help in there. What happened? Tell me. You've started implement pit stop after selecting the pivot row. You need to complete the remaining steps, calling the pivot row to make the leading entry 1. Whoa, no, I'm good. Which row are locked after becoming pivot row? Hey, how are you saying that this is incomplete? This is more than complete. You're checking which rows are locked. Yeah, oh, wait, yeah, this is what I'm doing. Rows with leading 1s earlier in the matrix should appear before rows with later leading 1s. Yeah, but this is still good. Yeah, I'm doing good here. I don't think I'm I don't know which model you guys are using here. You stopped after selecting the pivot row. How? No, I didn't stop after selecting the pivot row. Remember that the final ref should maintain the original row order unless row swaps are performed. I think that's my issue. And I think I'm swapping where I should not swap. Yeah. I think that's the issue. Because maybe there's no point in swapping at some point, but I'm doing it anyway. And if I have a -1, I should just skip, not swap. Yeah. Okay, wait. Let's print the matrix. Let's do the same thing as before, right? We're gonna go there, and we're gonna do the branch of printing. So print what we're doing here, matrix, and we're gonna do print f current column, call it I. I'm gonna debug this one print at a time. So first shot we're doing 1, 2, -1. I think we're good here. Second shot we have 0, 0. Why is it like that? Why we have a 0, 0, 1 and a 0, 0, -5? I know I just kept this. Did I ever swap in here? Did I do at least one swap? I never did any swap. So there's no swapping happening. But this one stayed, this one didn't stay. In their case, it's not this that happened. This one died off, and this one is linearly, it's the same thing. It's the same thing. But like a 0 spot. Okay, well, so this is, there's no swap happening, so that's that. And then is there skip happening? No, there's no skip either. Yeah, there's a skip happening. Yeah. There's a skip happening when we're here. Why? So there's a skip happening, and when we're doing the skip, we have that. So we're looking at column 1, and it is all zeros. Okay. So we should not skip, we should swap it? Why? Why should we do a swap here? What's the algorithm saying? So yeah, like they seems to want me to swap, or not even. I don't think it's that. I don't think it's about swapping or not. I think it's also gonna print the locked column, right? So print locked rows. Sorry. It would be nice if the debugging. Whoops. Locked rows. Is that it? So. Jeez. Locked rows. It'd be nice if the debugging was like following the new line and stuff. Because right now it's not. Okay, wait. So I have nothing in there. And then I'm doing the skip, and I have the 0 in there. Okay, I'll need to have some locked. Don't break on me. Okay, good. So the locked rows is 0, and then it's only just zeros. The only locked row here is 0. So it means what? Are we making a swap? No, we're not. We're never making a swap. Should we always lock the rows then? Like, is this what we're saying? See, like, as we go down here, this has to stay as is. And this is fair game, and we can swap these two together. Like, what the fuck? What are we saying here? I don't get it. I really don't. Because my last output, there's zeros at the end, and this one, there's not zero at the end. I'm skipping one step because there's nothing to do here. But by skipping it, I'm not doing a swap. Because otherwise, I would just go and do the rest, right? So, yeah, if I, okay. Like, I'm swapping. I feel like this is a bit bullshit. Select the, identify the first non-zero entry in the current leading column. Is it that by default I should do that? Like by default I should return like the last element? Yeah. I think it will break shit. Okay. Let's return row I. Always. So if we burn through everything, we're just gonna return the last element, so we're gonna swap, I guess. So there's not gonna be any skip. Oh, this is shit is messed up. What the heck is happening? What? No, nothing makes sense if we do that. Because now, oh wait, no, yeah, we just have to do row minus one, right? Which is the last limit. Nope, this is not the you know you messed up when you see it like non-infinity, right? Those are not nice to see there. No, this is not how we should be running this stuff. Yeah. So what should I do? Like, I feel I'm in the right. I feel I'm supposed to be doing okay here. I'm not breaking anything here. It's fine. But in this particular case, yeah, I'm not sure. I'm doing last element plus one. I don't know, man. Like, I'm skipping it. I should, like, telling me I should not skip that. Okay, let's say I'm not skipping it. Let's say I'm not, right? And instead, what I say is something dumb like my pivot row is gonna be equal to the row minus one. Let's say I say that, right? And I'll continue. Just go here. Is this gonna break everything? I think it's the same thing if I do it this way. Yeah. So I get 1, 2, minus 1. And I get 0, 0, 1, 0, 0, 5. And then in this situation, everything get obliterated. Like everything get absolutely destroyed. But why though? Why is it like? Why is it like that? Pivot row. Okay, wait, what the heck? Oh yeah. Wait, I'm gonna do this here. If anyone has any ideas here, I will be taking them. Right, so here, my pivot row is 1, but here there's a skip. So at this point, I'm 1, 2, minus 1, 0, 0, 1, 0, 0, 5. And then I'm done. Because I'm taking this pivot row, right? But if I say, right, wait, let's hard code some shit. So if I say my pivot row is 1 here, right? I'm gonna hard code that here. Why? This is where everything gets messed up. Let's say my, no, it's there, yeah. It's when I go to the current column 2 that everything get obliterated here. What if I see 2 then? Oh man, yep. I feel like something is off. I'm at the point where I might just swap them. Why is it that, like, is it the scaling that I'm doing that is messing everything up? Because, like, realistically speaking, what is happening that is wrong here, right? This one is there. Because at this point I have 1, 2, 0. Sorry, 1, 2, minus 1. 0, 0, 1, and 0, 0, minus 5. And I'm selecting this one to be the, and I'm eliminating everything else. That's what's happening. So the middle one gets saved, all the other one get wrecked. But it's as if it's telling me like, no, you should not skip it. No, I don't know, yeah. Should I swap them? Okay, let me print them from the top, right? Right here. Let me print them right there. Okay. What is going on when I'm at the top? Not that at the top, I guess. No, this is fine. I don't need it. So for those that just joined, I've been debugging this shit for like an hour. It's just a stupid debugging right now because it literally doesn't matter. Like, it's the same thing. Is there some definition that I'm not knowing about? I don't. Is this it? Is this like there's a definition that you should not? No, because this drawing is literally saying that like this is fine. You can have zeros here, which is what I have. I have zeros at the end, but they have a zero straight in the middle. I think this one is broken. I really think that this is, dude. I think this is messed. Yeah, I'm fairly certain, right? Fairly certain that I'm the right here. This thing is broken, and yeah, I do believe it. Because this is 0, 0, and then I have my 0, 0, 1. Yeah, I don't think I'm gonna change it. I think I don't think I have to change the algorithm here. I think the algorithm is just fine. Yeah, I think it's not an issue. Wait, this one is fine. This one is also fine. All good so far. But this one, the output that is expecting is this swapped for me. Which, to be honest, I think I'm good. Yeah, I think I'm good here. Okay. Is there any comment? Yeah, okay, perfect. I don't care. Okay. I think that this case might be a bit broken. The expected is I got sorry, I didn't repeat the test case number 4, and I got I guess the literal same solution, just with the empty row removed at the bottom. Okay, to actually be able to test this properly, what I think we should be doing, right, is there's in the test case there's a pass through that we're doing in the output to just remove completely in the dimension the rows, because these two are like they're linearly dependent. It doesn't matter where they are, right? Whether they're in the middle or at the bottom or at like completely down, it just doesn't matter. So I think like we should do like a sweep through it and pop them off, right? I propose that we during the test case we do a sweep through the result from the user, and that we pop all the rows that are empty and discard them. So the comparison can be done without having to take the order of the empty row in consideration. Okay. Who's with me? I think I'm pretty right here. Oh, wait a second. Oops. Okay, I think that's it. And is this good? Oh wait, I'm gonna put polar space. Okay, put that in code. Oops, what did I do? Oh, messed it up. Okay. Backtick here. Yeah, take it good. Okay. I knew it. I fucking knew it. Whew. Hey, deep. Damn. I'm basically testing this. Yeah. So that now that I got this one right, every time I'm gonna have a test that doesn't work, I'm gonna say the same shit. I'm gonna say like I'm right, the test is wrong. Um, and by the way, I think it's loading forever. Not sure what's up with that. Maybe it's the image that is too big. I don't know. Yep. Okay, cool. So it's good. I would I would I would put it as right for this one. I think I did it good. I think I did a good job here. Let's put it here. First try. Actually, first try I didn't get it. I got it in the second try. I got it here, but I still I almost got it 100% right at first. But which part did I mess up when I was doing it? Which part did I mess up? Oh no, I didn't mess up anything. No, I got it right first time, right? So I got it right first shot. The only issue is that the input matrix was in integer 64, I think, and the division for test case And number 3 broke because of a sub 0.5 number got crushed to 0. The starting matrix should already have been float before. Either this or yeah, no, like this is like, yeah, you could I could blame I could blame the problem and do it this way. I could have just done this and have like, I don't know, like the float here. I think that should have also worked. Right? Wait. I could have done this. Let's say I run it like that. It will not change anything. And if I do this, right, and if I do it like that now, it was the third one that was messing up. Because at this point, I'm going to divide by a float. So, no, it's not that. It's not doing this at all. Even if I do this here. Now, yeah, so I was right. Yeah, this one, like, you just need to cast it as a float first, right? And not have it as an integer. It's fine, because it's just weird that, like, you have to manipulate the matrix afterward. Yeah, it's just a bit weird here that you have to manipulate it to put it into a float. So I just recommend that we put it here as a float first. So this should happen before the matrix enter the user purview. But I think we're good. So say it's 120.0.0.1.0.0.0. I mean, it doesn't matter. Like, if you think about it, the two are linearly dependent. So, like, whether the 0 is, it has no impact whatsoever. I think, like, whatever the user will be doing, I think it's fine. And we could just, like, disregard that and just pop them off. But I mean, like, I just don't understand how your algorithm worked so that you get to the 0, 0, 0. Maybe I should look at the solution. Anyway, I think that's good enough. So that's it. So thank you everyone for attending the struggle. It was not too bad actually. Like, I think I did pretty good on this front. You can check it out. This solution. It's fairly straightforward. I think like the recipe is really well made. Like start with the leftmost column, select the pivot row, scale the pivot row, element above and below, and then move to the next column. The algorithm is fairly straightforward. And then if you implement it like slowly and then chunk wise, you can get it right first time, which is what exactly just happened. Like I got it right first time. So have a great rest of the weekend, folks. Check out the paper that I mentioned at the beginning, right? So continuous thought machine. I think it's awesome. You should check it out. I would say it's gonna be like maybe the next breakthrough if this thing can scale to language. Don't quote me on that. Maybe I'm wrong, but I think it's like one of the most biologically plausible model that I've seen so far. So that's super interesting. And also do check out DeepML. Big fan. Keep it up, guys. So that being said, see you everyone.